Our team name is Slam Robotics. My name is Milad. Our team consists of Ohwofasa, Yona, Jesse and Stefan. We've been focusing on Odroid robotics. We first started with home security, and the home security consists of cameras, facial recognition and video feed. Now, the main reason why we didn't go for this particular option is because there are so many in the market. Moving on to mail delivery. The mail delivery is basically the mail delivery robot delivering mails within the offices. Now the mail delivery consists of reading QR codes. We had the 3D mapping, so it knows where it was going. We had the ultrasonics to avoid any objects when it goes closer. Mail delivery consisted of a robot chassis as well to move the robot around the office. We didn't go for mail delivery because it was complicated and also hard to achieve with the existing equipment. We moved into line following robot because it's much more simpler and it consists of light sensors and LED rings. It also has ultrasonic sensors to detect any objects that are close by. Now the reason why we did not use the line following robot is because we found a better solution.
So the final iteration of our project was a 3D mapping robot, and this incorporated the Microsoft Connect that was embedded on top of the robot. And this used SLAM, which stands for Simultaneous Localization and Mapping, to 3D map a room. And we also used the Xbox controller to hopefully get it to move around and remote controlled. As well with this project, we attempted to incorporate bits from all the other iterations of the project, i.e. the ultrasonic sensors were meant to be put on the project to add for object collision. It was built on the robot chassis from the mail delivery part. We also attempted to put a second camera on top of the Connect, so that eventually we might be able to live stream from the Connect so that we could see what was going on basically and hopefully use it remotely. So I'm talking about the Connect mapping with the Xbox 360 Connect. So what we've got here is obviously the 360 Connect hooked up via USB to the Odroid, and this is connected to the monitor. And this is made up of the main software, which is Ubuntu Mate, which is an Odroid specific Ubuntu package running on the 14.04 kernel. And to get the Connect to work, we're using Point Cloud library, which has processing tasks including 3D geometry for mapping. The second bit of software is RTAB Map, which is real-time appearance-based mapping and supports SLAM, which also stands for Simultaneous Localization and Mapping. And that's simultaneous localization, so it sort of knows where it is as well as mapping a room at the same time. And then, as well as that, we needed the free NECT Connect driver to actually power the driver. So what it does is, we have it connected up and we run RTAB map on the Odroid, and you can see it's picking out my sort of portrait when you press it, and it's locating all the point clouds. And then once that's run, what it does is it forms a 3D mesh and a map on the Odroid, and we can view that later. It runs at a very low frame rate because obviously the tiny Odroid's powering it and we're restricted by processing power. And on top of that, it also can't map and view at the same time. And that's basically how it works. It all works at the moment, however, to get it working, we had to manually stop the Odroid from turning off the USB drivers, because as soon as it was connected, it would turn off the USB drivers. So to do that, I have to run a manual bash script every time we start it up to get it to do that.
As the idea of the project moved on to the in-office mail delivery robot, a robot chassis was required. The robot was supposed to orientate itself in office environment and avoid obstacles by itself. The chassis consists of two different voltage converters, as the motors require 12 volts and the Odroid requires 5-volt source. Another essential part of the robot is the motor controller, which would provide the capability of driving the robot in a specific direction with a specific velocity. It connects to the Odroid through the Arduino shield mounted on top of the Odroid. Once the Arduino shield is programmed, it can take commands straight from the serial port, which would allow us to create a program linking the keyboard buttons to specific motor movements. This is a very important feature, as with the progress of the project, the robot was no longer required to drive itself autonomously. The robot was now required to be remote controlled, as the new concept of the project is a 3D mapping robot taking its directions from the user. We considered a few different options for how to control the robot, and we decided to use the keyboard arrows for moving the robot forwards, backwards, and rotating it left and right. The downside of using these controls is that we cannot get the robot to turn left or right while going forwards or backwards. We decided to use these controls because we discovered that your droid is not capable of running the 3D mapping software quick enough to keep up with a rapidly changing environment. If the surroundings of the robot change quickly, the software would stop creating the map as it loses track of the previously captured images.
Hello everyone, I'm Efevberha. My task within the group is to come up with a solution that allows the team to view live feed of the robot as it navigates its way around the office. To do this, Motion was used as a solution. Motion is a command line based tool used mainly in security cameras. Software supports up to 4 cameras and is written in C language. In order to do this, Motion had to be installed. The files had to be configured to suit the functionalities required for the project. A head-up network had to be configured with a /30 subnet mask. Test results showed that even though a connection was established between the Odroids on the same local area network, live video feeds from the Odroid running Motion could not be viewed from other devices on the same network. After several attempts of trying to solve this problem, Ngrok was used as a solution to solving the problem of not being able to view live feeds on other Odroids on the same local area network. Ngrok is a software that can be used across different operating systems. It establishes a secure tunnel between locally running network and public endpoints such as the internet. So now we enter the Ngrok command and specify the port which Motion is running on. So that would be sudo dot /ngrok http://8081. As you can see, Ngrok is running. In order to view this from any other device, doesn't have to be a device running on the same local area network. It can be viewed from any device remotely. That's what is entered on the browser. http://6b9851b8.ngrok.io. It's entered on the browser, and as you can see, Ngrok is running on both devices.
My name is Yona, and as part of developing a mail delivery robot, one of the key tasks was for me to develop an application in order that enabled a webcam to detect faces. The programming language I used was Python. One of the key reasons why is because it had bindings available that allowed me to use OpenCV and Python to develop an application which strongly involved computer vision. The breakdown of the key tasks involved was to install OpenCV. The latest version was installed because they had more transparent APIs, and as well as having the features of the new features and the old features together provided less errors. The reasons in which why I use OpenCV was because the library was compatible in all platforms, allowing you to develop applications using the library on ARM processors as well as CPUs. Another key task which involved in developing the application allowed you to detect faces and eyes was using an IDE called Genie, and an IDE was just a program that enables you to develop applications. One of the tool chains that allow you to develop applications in general is an IDE, and I use Genie because of my past experiences in its ability to successfully compile really quickly in comparison to other IDEs, as well as its large icons, which is part of a broader aim for the IDE to be open to beginner programmers. And that's another reason why I use Python, because Python was an introductory programming language that allowed you to gain exposure to developing applications for computer vision.
This is the application running now. So as you can see in a window, this is the window generated as part of the application. So it's about to detect my face and eyes. You can see the green squares. One of the disadvantages of this is, I guess, it's the processing speed, because a lot of data is being processed across the Android. The frames become a bit slower than usual. But as you can see again, you can see the eyes and the face being detected in real time at the same time, which is key and which is different to our application. Thank you. Started. Action.
Hi, my name is Milad. So we use ultrasonic sensors for this sort of project. However, it was intended, but now we've come to a conclusion to not use it. Main reason why is for accuracy, and also that we've found a better solution basically for it. So if you zoom in here, ultrasonic sensor SRF05 has got inputs and outputs, and then it's got a voltage. All of these jumper cables is connected to the Odroid, to the Arduino side of the Odroid. However, the voltage is connected, the power is connected to the voltage which is on the Odroid side. Now we use the resistor to reduce the voltage and also the current as well, the current flow. As you can see that it's directly gone through to the LED. The LED is used, so basically the LED the way LED works is whenever the ultrasonic goes above 250, so anywhere close to 250, you can see that the light on the LED goes very, very dim. But when it goes close to an object, it becomes very bright. So that's what the LED does. Now it was intended to. It's the ultrasonic here. So obviously, and everything is displayed on the screen as shown. So that is the value, which is the centimeters. And yeah, so as you can see, anything, the higher it goes, the more dim it becomes, and the lower it goes, the more brighter it becomes. However, like I mentioned, it is converting analog to digital, and that's the main reason why we have an estimation and not an accurate ultrasonic sensor. So this is the reason why we're not using ultrasonics.